Humans are curious beings. For centuries, creativity has led to remarkable innovations. Space has been a dream for many, but projects within the TU Delft, like CubeSat Delphi C3 and the Student Rocket Society there, show that students can make it reality. The next step in space exploration is the Moon. This leap is being taken by student team Lunar Zebro. Zebro stands for zes-benige robot in Dutch, or six-legged robots. These legs enable a robust platform on the lunar rough terrain.
The Zebro group was started way back in 2013 with the goal of developing the Zebro platform that offers a flexible and inexpensive alternative to the big and complex rover platforms we normally see around the world. This concept was further expanded to space applications in 2017, and the Lunar Zebro came into existence. Current lunar missions are designed to go on solitary expeditions with one heavy-duty rover. This is where the Lunar Zebro project takes a different approach. We are building the world's smallest and lightest moon rover yet.
The Zebro rover has the footprint of an A4 sheet and weighs about 2.5 kilograms. Therefore, one of the biggest challenges within the project is miniaturization. This pushes our engineers to be creative in their engineering. A good example of this are the cameras on board the Zebro, which were designed in-house and have a mass of less than 2 grams each. The most unique feature of the Zebro is its locomotion, of course, which is done using C-shaped legs based on the REX project from the University of Pennsylvania. This enables the rover to traverse difficult terrains without getting stuck, and our in-house software detects which obstacles the rover must avoid and which it can climb over.
The first moon mission is going to be a technology demonstration of our system. We will send one rover to the moon where it will be exposed to the harsh lunar environment and will have to survive for a minimum of 14 days.
All components of our rover must be space-grade to resist the challenges, including extreme temperature ranges and abrasive and electrostatically charged lunar regolith. All of this poses difficult design constraints.
So since the engineering model was built in 2018, the Zebro platform has constantly been tested. This is facilitated by means of analog missions. So the Zebro takes on challenging environments like the lava tubes in Iceland or the mountaintops in Switzerland, and the results from these tests are used to refine our system.
By walking on the lunar surface, our Zebro will provide valuable information on the effects of regolith on materials and electronics. Also, our rover carries a scientific payload, which is a radiation sensor that will measure the levels of radiation on the surface of the moon. Overall, the first mission for Zebro will be 1 moon day or 14 Earth days long, and during this time, the rover will communicate directly with our ground station network to send data and receive commands. The Lunar Zebro has been designed in such a way that it can be adapted to piggyback on any commercial or national agency's lander and hitch a ride to the moon.
For future missions, we envision multiple Zebros to form autonomous swarms. With a swarm like this, we could explore caves and other risky terrains where a conventional rover might not dare to go. Also, searching for specific features or things becomes easier since swarm can cover a much larger area at once. Besides that, swarming also allows us to unlock missions that would otherwise be too expensive or difficult, such as measuring cosmic background radiations on the far side of the moon. Traditionally, this measurement would be done with a large radio antenna, but a low-cost alternative is to recreate it with small antennas on each Zebro in a swarm.
Swarming, of course, has many terrestrial applications as well. Think of monitoring of a farm or a warehouse, search and rescue in an emergency, or using sensors on top of the Zebro to detect dangerous situations. We have to realize that engineers only make the first invention. It is society that makes the second invention, the real use of the application. That is why we are so committed to outreach beyond our university.
In essence, the Lunar Zebro is a space mission. However, what really sets us apart is that this has entirely been conceptualized, designed, and implemented by students. Since the inception of the project in 2017, almost 120 students have now been a part of the project, and this is their legacy. The Lunar Zebro will be not only the first Dutch mission to land on the moon, but also the first European. And the fact that this comes from a technical university in the Netherlands really shows the world what TU Delft is capable of and makes it attractive for aspiring students. The project also facilitates vertical integration of education, as students from university work together with students from higher vocational studies.
Lunar Zebro is first and foremost a vehicle of education for students, where they can get rare hands-on experience in a real space mission. Our goal is to educate the next generation of engineers in space applications, and one of our biggest contributions to Dutch society is a steady supply of well-trained engineers. But it doesn't stop at that. Several students have taken their ideas and skills to the Dutch space industry, where they started their own companies.
The project also acts as a bridge between university and industry. Several industry partners support the project with their technical critique, test facilities, or in some cases even their hardware. Thus, this is a collaborative effort that delivers a product that generates immense value for the scientific community.
I'm convinced that it is human curiosity and the ambition of our students which will lead to the world's smallest and lightest rover yet on the moon.